Right, good morning students. We'll be doing your first experiment in chemistry today, that is general chemistry. And as I explained, we'll be preparing some solutions. And the solution will be made out of, one is oxalic acid. We'll be preparing 0.1 normal oxalic acid solution. The other one will be preparing 0.1 normal sodium carbonate. We'll also be preparing 0.1 normal NaOH solution and 0.1 normal sulfuric acid solution. So we'll be preparing 4 solutions today, and as I explained, 2 of these solutions are secondary standard and 2 are primary standard. So the primary standards are oxalic acid and sodium carbonate, and the secondary standard is your sulfuric acid and NaOH solution. So we'll be preparing these primary standards and secondary standards, and the same very solutions we'll be using in your next experiment for the purpose of standardization. Right. So let's start with oxalic acid. Weighing the oxalic acid now, which is this is the weighing bottle, and I'll be weighing exactly 1.575 gram of oxalic acid, which is as per our calculations, for preparing 250 ml 0.1 normal oxalic acid, we are in need of 1.575 gram of oxalic acid. So after placing this weighing bottle, it's very important to adjust the weight to 0. So I've pressed a 0 knob here, which takes the total weight to 0. It's also important to close the lid because air can influence the weighing. So you can see, I'm sure it's not visible, but it's slightly higher than 0, so I have to again press because I've just closed the shutter. So now it's perfectly 0. So I have to take 1.575 gram of oxalic acid. So I'll be taking out oxalic acid, which is a primary standard. So as I explained, primary standards always gives you exact concentration solutions. When it comes to secondary standard, due to their nature, sometimes they are hygroscopic, sometimes they decompose. So there are multiple regions that some substance are not giving you exact concentration solution. So oxalic acid is one such substance which is regarded as primary standard because it always gives you your desired concentration solution when you prepare. So I'm weighing 1.575 gram as explained. Okay, so after weighing this, we'll be transferring this substance to a volumetric flask. So I've pre-labeled volumetric flask for preparing oxalic acid is 0.1 oxalic acid labeled over the flask. This is the flask, we will call it volumetric flask, and they come in different sizes. I have to prepare 250 ml, so I'm using a 250 ml capacity volumetric flask. So what I have to do is now I have to transfer the content of my weighing bottle, which is oxalic acid, into the flask. For doing so, I'll be using one beaker so that I can transfer it properly. So I'm transferring the solid substance into the beaker, and then I'll be dissolving this solid into distilled water. So this, I have a squeeze bottle with the distilled water inside. So I'm pouring the distilled water into the weighing bottle as well, so as to ensure that the entire solids which I have weighed has been transferred to the flask. First I am transferring it to the beaker, then later it will definitely go to the flask. So after doing so, you have to stir it with the help of a glass rod. Just stir the solution, dissolve it. I'm taking some more distilled water to make sure that it dissolves properly. So now we can transfer the content of the beaker to the flask. I'll be doing it multiple times to ensure that my all solid substance is transferred, or the solution is transferred to the flask. There are some solid particle which I can see. I'm still dissolving it to make sure everything goes into the flask. Keep doing it for some more times, 2-3 times at least, to make sure that everything is being transferred. One more time I'll do. Alright, so since I've used the funnel, I will make sure that whatever is stick to the walls of the funnel is also being transferred. So now I'm sure that all the solid which I have prepared has been dissolved and transferred to the flask. So as this is a 250 ml flask, and on the neck of this we have a mark which may not be visible to you, but there is a mark here. So I have to make the solution up to this point, so as to make a 250 ml solution. Now, if you could recall your understanding of normality, it always says that the solute plus solvent should be together 1 liter. When we are preparing 1 liter, in this case we are preparing 250, so the solute plus solvent should be 250 ml. It's not like that you take 250 ml water and then add the solid. No, solid plus the distilled water should make it 250 ml. So I'm just pouring in some more distilled water. So I've stopped at certain stage because I know that I have to add carefully afterwards, because I have to make it up to the mark on the neck. So now I'll be using the squeeze bottle to take this volume up to the mark. Alright, so now my solution is ready. Just stopper it and tilt it to make sure that it is a homogeneous solution. So this is our 0.1 normal oxalic acid. The same way we'll go for other substances Let us now prepare sodium carbonate 0.1 normal again. So this is the sodium carbonate solid, and I have to weigh 1.325 gram of this. Taking a fresh spatula and a fresh weighing bottle, and again I'll be pressing the 0 knob to take it to 0. Now I have to take 1.325 gram of sodium carbonate. Sodium carbonate again is a primary standard, so it's going to give us the desired concentration solution. So I have to take 1.325 gram of this. Alright, so now I'm done with my weighing, so I'll go with the same procedure again to prepare 0.1 normal sodium carbonate solution. So I have to go the same way. We'll transfer the content of the weighing bottle to a fresh beaker. To ensure that all solid substance has been transferred, so the weighing bottle will also be washed with distilled water to transfer the content. Then I'll be dissolving this into some water using a glass rod again. again make the volume up to the mark with the help of squeeze bottle. This to be done very carefully so that you are right at the mark. Okay, stopper again and tilt it to make sure that it's uniform homogeneous solution. So this is your 0.1 normal sodium carbonate. We'll go for the third one now, which is your sodium hydroxide solution. Which sodium hydroxide is a secondary standard. So obviously secondary standard, as we know, are usually substances which are hygroscopic or unstable kind, or which decomposes. So I have solid sodium hydroxide pellets here. So I'll be weighing exactly 1 gram of sodium hydroxide. So I'm taking a fresh weighing bottle, and again I have to make sure that the display is at 0, so I'll be pressing the 0 knob again, and now I have to take out the pellet. Sodium hydroxide is secondary because of its hygroscopic nature. So I have to make sure that my spatula is very dry because it will absorb moisture otherwise. So I'm taking out the sodium hydroxide pellets, and it should be 1 gram I have to weigh. Alright, so since it's pellet, I cannot weigh it very accurately because of the size of the pellet, but I weighed exactly 1.02225 gram. So I'll be now transferring these pellets to the another volumetric flask, which is again pre-labeled with 0.1 normal NaOH. So again take a fresh beaker, transfer the pellets, wash with some distilled water. So now dissolve the sodium hydroxide pellets into water. Okay, so your third solution of sodium hydroxide 0.1 normal is ready. Again, give it a tilt to make it homogeneous. So finally we are going to prepare now a acid solution, that is sulfuric acid solution. Sulfuric acid, of course, we all know is a liquid, so our calculation, as I explained, we need sulfuric acid equivalent to 1.36 ml. So I'll be taking out 1.36 ml of sulfuric acid. So some sulfuric acid I'll be taking out in the beaker. So sulfuric acid again is a secondary standard and again a hygroscopic substance. So I have to take out 1.36 ml of this substance or this solution. So I'm using a pipette for measuring this. Alright, so I have a 5 ml pipette here. So I'll be using this pipette to take out 1.36 ml of sulfuric acid out of the beaker where I've taken out the concentrated sulfuric acid. So first thing to do is to range your pipette. So for preparing acid solution, one thing we need to take care always is that we should not add water to acid. Rather, we should add acid to water. So what I'm doing here is I'm taking some distilled water in a container, in a beaker. First I have to arrange it so that I can transfer the acid to water rather instead of adding water to acid. So it's some water I've taken in advance so that I could transfer my measured amount into that water. So if you add water to acid, there is a good chance of an accident taking place, because what happens is the water bumps. So if you add acid to water, it will be a very vigorous exothermic reaction, and it can, come on your face. Okay, so this is 1.36 ml of sulfuric acid going in some distilled water. So since already I've taken distilled water, so it will not cause any vigorous reaction. So I've transferred the sulfuric acid into water. Obviously it will dissolve in water, because this is sulfuric acid is a hygroscopic substance and readily dissolves in water. So now, as before, we will be preparing sulfuric acid solution. This time we are preparing 500 ml, because if I prepare 250 ml, I have to measure half of 1.36, which is somewhere around 0.68 ml. So which is difficult to measure. So we decided to prepare 500 ml. So this is a 500 ml flask. So I'm transferring the content now to the flask. Keep adding distilled water to make it 500 ml. Take the volume to the mark. Again, stopper the bottle, volumetric flask, and tilt it to make it a homogeneous solution. So now your 0.1 normal sulfuric acid is ready, which is a secondary standard. We have a secondary standard in NaOH, which we prepared. We have primary standard in sodium carbonate, and we have a primary standard in oxalic acid. So we have prepared 4 different solutions today, and we'll be, in the next experiment, we'll be using the same very solution to try to find out the concentration of secondary standards, which is sulfuric acid and sodium hydroxide, with the help of our primary standards. So we'll meet again in the next laboratory, where we'll be using the same very solutions to find out the concentrations. Thank you very much.